So this video will be talking about a brief review of domain and range and relations and functions. So I typed up some notes here for you. First of all, going back through the basics, what is a relation? A relation is just a set of ordered pairs. So we have an example here right underneath of that where they're just listing out a set of them. This could be provided as it's listed here. It could be given as a table. It could also be just a graph. And it could be as simple as just a couple ordered pairs, like this one has 4, for example. It could be like a parabola. It could be a linear equation. Anything that has at its most basic set of ordered pairs is considered a relation. Now, the main topic of today is domain and range, so we'll spend a little bit of time on that. So what exactly is that? As a recall, we remember that domain is the set of all x values, range is the set of all y values. So if we look at the example that was given for the range, when we're writing domain and range, when it's just a set of a couple ordered pairs, we use those squiggly brackets, or S brackets as they're technically called, and we just dump into them each of the x coordinates and each of the y coordinates. So the domain for what I highlighted in green would be 1, 2, 3, and 4. The range, then we take the y values out of that, and the y values are 5, 6, 7, and 8. And always close with our squiggly brackets. Okay, so we have 1, 2, 3, and 4, 5, 6, 7, 8. If ever there are any repeats within the domain and the range, we don't have to write them twice. Technically, we shouldn't do that. So if there would be like another ordered pair that was 1, 4, or something like that, we wouldn't have to write the 1 twice in the domain. Now, when we're not just given a set of ordered pairs, perhaps we're going to be given a graph to look at. We have to talk about interval notation. So the domain and the range can be given to us in brackets or parentheses. We'll see what that means in a second. But you see here that the domain is given from left to right, and the range is listed from top to bottom. So if we were looking at an example, let's say they graphed for us a parabola. And maybe this point is down here at -2. Well, the domain, if we're going from left to right, the first thing I hit on the left is the arrow. And the last thing I hit on the right, let's use the pen instead, is the other arrow. So as this parabola is going upwards, it's also going out left to right. So it would be all real numbers, which we can see down here at the bottom. I have a fill in the blank. All real numbers is always parentheses with -infinity to infinity. Or you can just write out the words, but that's the interval notation for that. So the domain for our example here is negative to positive infinity. The range then, we go to the lowest point on the graph. So the lowest point is -2. And because that is an included value, meaning it's not an open dot or something that we're just brushing up against, we put a square bracket around it. And then if we go to the top of the graph, again, we hit arrows when we go the way to the top. So it goes to positive infinity. If we were graphing something and let's say they did an open dot and then maybe that was the direction. So let's say that that's 1. The domain here would be 1 to infinity because the 1 is not included, but like 1.00001 would be an included value for us for the domain. So that's the difference, what they're trying to describe over here with the square brackets and the parentheses. When we're not given just a set of ordered pairs where we're writing a list, we want to use square brackets and parentheses for interval notation. Last thing is a quick recap, is our review of functions. And if you recall from Algebra 1, a function is just a relation, so a set of ordered pairs, in which every element of the domain is associated with exactly one element of the range. And in short value, what that means is that x cannot repeat. So if we were looking at the example that I highlighted over in green from earlier, if I look at the x's 1, 2, 3, and 4, none of those values repeat. But if I, for example, were to add another ordered pair like we had talked about earlier of like 1, 4, well, now I just made that not a function because 1 goes to 5 and it also goes to 4. An easier way to see this graphically is by passing the vertical line test. So if we're looking at a sketch, so a parabola, good to go. Vertically, let's change colors here. If I draw vertical lines going through here, it's not going to touch the graph more than once. So this is, yes, a function. But if we looked at something like an ellipse, which is kind of this ovular shape, I could draw any number of vertical lines, and because that x value, whatever it is, has 2 y values, that's not a function. Or I could look at what I highlighted in green from a table perspective and again, be looking for x's not to repeat. Or you could graph those points and check it on the graph. Use vertical line test for everything. The last thing we want to take a look at with this is from an equation perspective. So if we're using the concept of whether or not it's a function, we can actually check this using an equation. So an example of that, let's say that we're looking at the function x squared plus y equals 1. If we solve for y, so we get to a point where we could actually graph this, we'd have 1 minus x squared, which is a parabola. We don't have any issues plugging values into that. So that would, yes, be a function. If we were to graph that, it would be an upside down parabola that shifted up 1. However, if we looked at this example, let's say x plus y squared equals 1. Well, now when we solve for y, so we'll get y squared equals 1 minus x. And when we solve for y here, we got to take the square root. So that means that the y values are going to be positive or negative of 1 minus x. And that's a problem for us because that graph is going to look something like this. It's going to be like a C shape. And obviously in this case, we're going to have something above the axis as well as below the x-axis, so it's not going to pass vertical line test. So this one would be a no. So at this point, you can go into Google Classroom and check out the practice for domain and range.